Hello guys, my name is Adrian and welcome to my channel. If you are new to the channel, I'm trying here to create a small framework in order to be used for some game that I'm developing live on stream. So far, we created for our framework the window, whatever takes for a window to work. We have events, inputs, and so on. And we started our journey with OpenGL. So far, we implemented some commands, the vertex array, and the buffers. We kind of had the, let's say, the mechanisms to load the content of a file in order to be used as the shader source. And also we saw how to convert the text format of the GLSL, the shader language, into some binary form that it's used also by Vulkan. It is called SPRV for those that don't know. And today is the time to kind of create the shader objects that we will use in order to change the color of our small quad here. So, because we are not using any existing library from the internet, I kind of created, like for the previous OpenGL objects, I created some functions. Okay, so we have the normal creation and delete function. For the shaders, we have two functions to send the content of a shader to the GPU. And for the program, we have also the creation and the deletion. And what we have there, it's also the linking. We have these two functions to attach and detach a shader. So how it is working? Most of the time, if you are working with Unity or Unreal already, in those programs you don't have the concept. You have just the concept of the shader, but you don't have the concept of the programs. Like I said in the previous videos, a shader in OpenGL, it's mostly like a small program that runs on the GPU. So when they created the OpenGL, they kind of created this, let's say, notion of a program, and after that of a shader. So what we'll do today, we'll keep for the OpenGL program and the shaders. Those are already loaded in here. Okay, so we have valid, let's say, pointers to those functions. But what we will do today, we will create two new classes inside the OpenGL, and one will be the shader, which for us, it will be something that will be based on the program. Okay, and what we will do further, we'll have something like something like shader stage. In Vulkan, you don't have the program, you have these shader modules, and you have also the shader like we have it also here. And those that are not attached to a program, they are attached in a different way in the Vulkan. But we will talk about that later on. So what we need to do further, of course, we need to make sure that we are using the program CPP. Sorry, not program. I just said that we will not use it. So we'll have the shader and the shader stage. What we need to do further is to change the namespace to OpenGL, because this is what we are using. Okay. That's so far one thing. And we will start with the first element, the shader stage. Like I said in the previous video, and we already have inside the resource module, we have some empty files for the shaders, something that we called base shader. So we need, for example, we have one for the from fragment and something from vert, which means it's meant for the vertex shader. I would like to have this fragment and vertex called stages, shader stages. So what a shader stage will mean for us, it will mean this type of shader. The stage can be fragment or vertex type. Later on, we will do something about the tessellation and other geometrical and whatever other shaders we have and when we will need. But for now, the basic that you need is the vertex and the fragment. So let's start. In the shader stage, let's also try to make a small run to see if we... Okay. Seems that they didn't. Just a second. It seems that we have. Anyway, let's continue. So in here, we'll include the object HPP. Okay, because all my objects that are related to OpenGL we have an inheritance from this object. So we'll have class shader stage final. Of course, we'll make, like I said, a small inheritance from the object. After that, of course, we need to have the create and destroy, because this is what our object class kind of restrict us to do. And further, what we need is some source, okay, which should take an std. What I will do, it will be a vector, char, and something that we'll call source. Constant and void, and later on what I want to have a setter function, which should be like UIint32 type, and this will be, sorry, not constant, this will be void. Okay. For the type, we will use this property info that every object in OpenGL should have, in our framework at least. And we will start to implement these functions. Let's create. I want to make sure into the headers that we are using the program and the shader. We are doing that. So what we will do first? What I want to start with an assert here that, just a second, let's use the macro assert here. I want to start with an assert that my info is not null. Okay, it's different than 0. Okay, we have something there. It's very important. Why? Because for the shader stage, we need to set the type of the shader stage. Like I said, we have two options for now, vertex and fragment. So it's very important when we are creating the shader to kind of have this info available for us. And we'll call the functions create shader. And for it, of course, we need to have a type of the shader. For the destroy, very simple, delete shader, nothing very complicated. And the part that is a little different now, for the source, like I said, we are using binary format, so we need to use two different functions that you are kind of used to. One is shader binary, which should take the first parameter 1. I don't know why they put count parameter there, but you're kind of allowed in a way just to use 1. We'll have the handle. We need to use some constant which we inform the GPU that this is in the binary format. And especially this macro has some information that is kind of tell us that it's SPRV. I named it with binary format, not with binary format SPRV, blah, blah, blah. I wanted to kind of be more lean on the naming here. We're having source data and source size. Another function that we need to use is called shader. Let's see how I created shader. Just a second. I forgot. Okay, it's called specialize shader. Okay, we can have something like we can name it different after. So it's specialized shader. Okay, handle. We need to put an entry point, which is the main, which should be the same as this, the main function. This kind of allows you to kind of have another name if you want, but main sounds pretty good. And the last parameter will be null pointer. These parameters are for some constants if you want to send. We don't use them, so we kind of don't need them. Okie dokie. Now, the last part is info equal with type. Okay, that's very important. And how are we using this class already? Now, what we can do in here, for example, we can have something like base vertex shader. Okay, and we can have, of course, first let's include the OpenGL shader stage. Very important. And what we can have here already, it's something like OpenGL shader stage, something like this. No, let's do it a little different. So we'll have something like this. And what we need to do further, base shader, we need to set the type OpenGL constants, and we'll have the vertex, for example, and later on base shader vert create. And what do we need for the create? We don't need any parameter. And what we need to do further, it's base shader vert source, and we are sending this, the content of this file. Okay. And now we kind of need to do it also for the fragment. So I will have something like this, OpenGL shader stage, and we have the fragment. We put create, and for the source, we are sending this source. So now if we are trying to run, everything should be okay, or it should crash. One way of doing that. So we successfully compiled to, let's say, shaders. And now what we need to do further? We are moving to the shader class. For the shader class, we will need to, we need to include the shader stage. We'll have some final here, public object. Of course, create and destroy. We have a function because for this program, we need to attach some stages. So for each shader, you need to attach the stages. So we'll have something like shader stage, and we'll call it stage. We'll make it a constant, and this is it. After that, we will have also detach. And by the end, we'll have the link. What the link means, it's something like after you attach the shaders, you are doing this linking. It's something similar to the C++ libraries, so you kind of need to attach those stages to this program that it's running on the GPU. And then in the end, I will have another function, bind, which is also constant and void. Now, what remains for us is to kind of generate these functions and to try to make use of them. In here, it's not mandatory to have some info. For the shader, you don't specify a type or so. So we have functions, create, and we call it create program. Like I said, I know that we are in a shader class and we are calling it program, but this is it. It makes more sense from my perspective in a framework to have something like this, okay? Just a second. So now we have also the functions and delete program. Just a second to check if for the shader stage I called the right one. And for the attach is very simple. We have a function which is called attach shader. Of course, the real name is GLSL shader. You need to specify a program and some handle for the stage. The same applies for the detach. And like I said, for the linking, you have this link program, which mostly kind of just attach those shader stages to this program. And later on, for the binding, I know that I have this function that is called bind program, but in fact, this is called GL use program. Okay. So what remains for us to do? Something very, 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 very simple. We need just to have something like an OpenGL shader. We'll call it base shader. We need to create it, of course, and we attach both of the stages. We need to link it, and what we need to do at the end, before we are kind of, let's say, using the square VAO and we are binding the information for the squad, what we are having something like shader, base shader, bind. Okay. Let's run this, and we don't see anything. Why we are don't see? Because we are kind of attached to our, so the information is still there. The quad should still be there. But the problem is that we are using some shaders and we are not doing anything in those shaders. So how do we kind of, let's say, solve that? First, if you remember, I'll put this main here. And if you remember, for example, we had this attach attribute, which takes some parameters, some information, and we send it to the vertex array. Now we have this base shader vertex. We need to map this vertex attribute in here. How do we do that? Layout, location equal to 0 in vec3, and we will call it, for example, in position. Okay, so if you are reading is something like this, 0, sorry, I speak in my native language. So we have 0 with 0 here, 3, which means that we have 3 floats, which means vec3. Okay, very simple. And after that, we don't need anything. So we have a name. How that works more than this? We have some built-in variable, which is called GL_position. And this is of type vec4. So what you need to do is to have a vec4 in which we put our vec3 position, and we say that the last parameter, it's 1.0. Okay, 1.0 for GL position, it means that is a, let's say, a position in space. If we had 0 here, it meant that we have something like a direction. But if you have an actual, kind of with quotes, an actual position, we need to put 1.0. There are some discussions about names that word space, camera space, blah, blah, blah space. Let's not talk about that, okay? Most of the important part, when you want to display something that you can see, put 1.0, okay? If we are running the code now, nothing it will happen. But what we are telling to the our shader is that, hey, you have some data that it's kind of entering in your program through this vertex array, and you're kind of saying that, hey, for your built-in variable GL position, you want to have this information. Now let's do something about also for the fragment. So for the fragment, we are doing something like this. We'll have a layout at location 0, and we'll have an out vec4 out color. Okay, and in here out color, it will be equal with this value. We'll have 1. This represents RGBA. We'll have 1 on the red channel. What we are saying here, so for the vertex, I had some input information that I took from here, and for the fragment, you need to get some out information. So something gets in, something gets out. So this is how you kind of do it. Okay, so what I'm saying in the main function, I'm saying that, hey, my out color should be red. If I did everything correct, if I run, I should see my, let's say, quad back, and it should be red. Why for a while it disappeared? It's because I started to use shaders, and it means that with shaders in general, you can, let's say, manipulate the information, the geometry, for this is how you kind of make lighting and so on. if you don't apply this transformation and all that stuff, it will kind of look like before. Okay, like just simple plain white, and that's it. So this is it for today. Sorry for the 20 minutes video, but this is what we have for now. Because we are having shaders, it is much easier to unlock some things. The next things that we need to take care of, it's the transformations. And we will talk a little about the matrices, the vectors, how to send them to the GPU, how to kind of have some, let's say, projection matrix in order to see this, because we know for sure that the geometry, it's a quad. But because it is a little stretch, but if I will have, for example, when I started a window that was like a quad, for example, 800 by 800, we'll see it as a quad. Okay, so in the next videos, we will talk about a little bit about math, especially matrices, and a little about vectors. And after that, we'll continue with textures, frame buffers, and the rest of the OpenGL objects. If you enter the channel, this is a good chance to subscribe. We are still at the, let's say, the start of the journey. Also, I had also the second live stream here on the channel. And as we advance a little this more framework, we will kind of have those frequently until we will have them daily. So, thanks for watching. Have a nice day. If you like the video, a like is appreciated. If you have any question, feedback, and so on, I'm pretty active, so you can leave a comment and I will respond. Have a nice day and see you in the next video.